Hello, I'm going to go over some of our sample problems. One sample problem was to take a piece of code, I've illustrated here, and rewrite it as a while loop and a do-while loop, separately of course. First thing I do is I write down the original. The original, we notice, has a variable n that is not seen anywhere in the 3 lines of code. That means it's assumed to be someplace. So in my example, because we later ask what is the answer when n equals 3, I just write it in here. Next, I take this piece of code and I rewrote the original and I put it inside a function called original. So I can test this later. So we simply see our loop, and notice it says 3 times I. That's what it's executing in here. And this is a shortcut for sum equals sum plus 3i. So sum starts at 0. So we have 0 plus I starts at n. Say 5. 5 times 3 is 15 plus 0. So it'll count down multiples of 3, starting at 5. And each time it counts down, it'll accumulate a sum. And then at the end, I'll ask what the sum is. So here's my first rewrite. I put it in a function called rewrite. And I want it to look like the original as much as possible. And I look here, I say I equals n. So here I have I equals n. Sum equals 0. Oops. Got a little carried away here. There it is, my I equals n, my sum equals 0. Even though I is in the loop here, I have to pull it out. So I pull it out. So here's I and there's sum. And again, n is assumed during a quiz. You just assume your professor or grader will put n equals 5 or some number someplace. Right here I see I greater than 0, so I say stay in the loop while I is greater than 0. So I've done exactly what the for loop has done. What has the for loop done? When it comes in here, first thing it does is say I equals n. First thing I do is say I equals n. The next thing it does, it checks to see if I is greater than 0. I check to see if I is greater than 0. The next thing it does, it goes into the body. Next thing I do is I go in the body here. The next thing it does, it says I minus minus. The next thing I do is I minus minus. The next thing it does is checks to see if I is greater than 0. I check to see if I is greater than 0. So this loop is actually syntactically different, but logically equivalent to the first one. Now I have rewrite B. I use a do-while loop. Do-while loop, initially I start off with I equal to n and sum equals 0. Now, here I have a little bit of a dilemma. The little bit of dilemma I have is because I test early here and I test early up here. So technically, I'm not 100% here. If I wanted to be 100%, I might just have an infinite. I could cheat and just say I greater than 0, break. I don't know, it's quite a cheat. And then here I just say, just always stay in the loop. So basically, this is now exactly this loop here. Because I stay in this loop when I is greater than 0, otherwise I immediately break out. I stay in this loop, otherwise I immediately break out. I'm going to go back. Control Z is an amazing thing. And I went back too far with my amazing thing of Control Z. Here I go. And I output the answer. Next, you have a question that says to encode the following rules in C++. For full credit, the code should be efficient in terms of speed. So we take a look at these rules. They're pretty complex looking rules. T is greater than or equal to 90, then the HVAC, which means heating, ventilation, and AC unit, turn it on. And you assume you have these things called turn on. You assume you have a function called HVAC. You don't have to worry how it works. if the temperature is between 90 and 80, inclusive, that is inclusive with 80, then turn it on. If T is less than 80, but greater than or equal to 70, turn it on. And if T is less than 70, turn it on. Well, you might sit down and start writing out nested if-then statements, which wouldn't be, well, it's not the answer. But if we look at it and think for a few minutes, we find out the AC unit is on all the time. So the answer is just turn the AC unit on. All 4 rules just boil down to this. It's trying to see the forest in spite of all these trees in the way. Another question was, you're given this sentence: if T is greater than 90, whatever T is, temperature, and day is not equal to 6, then turn the red light on. Well, 2 reasonable answers are, if T is supposed to be C++, if T is greater than 90 and, notice the double ampersand, notice and, I used the word not here, and now I use the exclamation point not, day is equal to 6. Notice the parenthesis here, yes, parenthesis, left and right parentheses are matching. Turn the red light on. Notice the word then disappears. This is just a quick question. It's for the 101 class, really, to see if they can convert problems in English language to a C++ language. And another reasonable answer is T could be greater than 90 and day is not equal to 6. Turn the red light on. And I said maybe that's better to look at than the first one. Next is a bit trickier. It says prompt and get 3 integer values, n1, n2, and n3, from the users or user. Then display them, the numbers, display the integers, not the users, in decreasing order. All right. One really quick way is, if you know in algorithm, there's a program called sort, STL. You could simply say enter 3 integers, use an array. When the person types in a number, A0, A1, and A3 get filled with data. And then I say, hey sort, go to the first member of the array, A0, go all the way up 3 memory bytes. So we'll go 1, 2, 3, and put those things in order. And when you're done, print out A0, A1, and A2, and the values will be switched around. A more difficult way of doing it, sorted 2, again, enter 3 numbers, but there I just put A, B, and C over here as 3 fun-loving variables. And I'm pretty clever here. I don't use any brute force method. I'm going through every combination and listing them out to see which is high, low, and in the middle. I ask, if A is greater than B, then I want B in front, so I'm going to swap. Notice, if A is too big, put B in its place. Then I'm going to check B. Now, I could have switched these two. Now I'm going to check B and compare it to C. And if B is too big, then C must be on top of B, so I'll swap them. So now I went through A, B, and C. Now I have one more pass to do. I called it a pass on purpose. Check A to see if it's greater than B. If it is, then swap them. This is actually a bubble sort. Swap is a built-in C++ template that will swap simple integers. And when I'm done, A, B, and C will be in order. The next problem was pretty simple. Just change this to a 1,000 or 10,000, whatever it asked for, 10,000. So I called it search 1,000. And it simply loops through. And it says, look at each iteration of I. If the remainder is 0, that means it's divisible by 5. Print out the I, because the I is divisible by 5. But then I also ask another question. I also didn't exactly do this in the most elegant way now that I look at what I did. I turn around and I say keep track of the row. I have a second variable here, row. And I say divide the row by 6. If the remainder is not 0, then I didn't print 6. Actually, I should call them columns. I didn't print 6 things across the screen. So if I didn't print 6 things, just put a space. Otherwise, give me a new line. And this will print everything up neatly. Of course, what I'll do is I'll make this columns of, say 20, so I can actually read it. On an exam, I pick wild numbers like this just so that somebody doesn't try to print something out 10,000 times. Like, I will do something 10,000 times, all right? So I build and run this thing. And here we go. Here we see, I'll go up to our first functions here very, very quickly. We see that they both 45, 45, 45, and that's when n equals 5. So I'll put some numbers in here. I'll put 90, 56, 33, hit the enter key, and sort 1, we'll put them in. Their correct order. Now sorted number 2, same thing, 22, and it puts them in order. Next, I had to print out multiples of 5 to 20, not the most exciting. So I'll change that just to make it a little more exciting. I like excitement here. I'll put 100. That's probably why I put 100 up there. Next, I don't want too much excitement, so I'm going to comment these things out. I don't want to see them again. So you'll see here 1, 2, 3, 4, 5, 6 rows of 6. Every sixth one, it'll output this ternary operator. Ternary because it takes 1, 2, 3 items. Notice item number 1 is up to the question mark. Item number 2 is between the question mark and the colon, and colon is the last item. This conducts a test. If the test is true, I go here. If this test is false, I jump over here, and this is the value that's returned. And notice I simply say, whatever this gives me, just send it to cout. And